Hello everybody, on my next stream today we will be solving problems from Codeforces, mainly div1 A and B, so div2 C and D. Let me see, tell me if something is wrong with video or audio. As a test today I have added in my top left corner a small text that will show you what problem we are currently solving, what might be useful to later go through the video and find a problem that you want to find. And since it's like a test, I must adjust it a little bit, but I guess it's readable. So of course we are not solving right now problem from round 999, but I will update it later. Hello Ayman, hello Sazat. Okay, so I got an idea to solve some problems when I took a look at recent contests, and I don't really absolve things in recent weeks. Sorry for a moment. So as you can see, this list of contests is quite empty in terms of absolving recently, and I'm going to fill that a little bit. Okay, so today A and B problems mainly, but also maybe sometimes an easier or harder problem. And we will start from the most recent contest, the one from yesterday. So Codeforces 517, and we will start with A. I'm posting a link to the contest. Hello Letan. So link to the contest goes here, and we'll start with cram time. So this is 517A, and let me professionally change everything now. So 517A. Okay, so you should see it all the time in the top row of the screen. Okay, as usually, I will read it, and also I will give you like a minute to just let it sink, to think a little bit, because it's more valuable this way, and then we'll go. I will go for a solution. I don't know solutions to those problems, so sometimes I can be stuck, but I hope, since those are not very hard problems, I will manage to move maybe in 20 minutes per problem. We'll see. So Lesha has 8 hours, and he has to study for 8 hours tomorrow. Okay, so there are multiple possible notes that he can read, and note number I can be read in I hours. So this sentence is the most important one. Lesha can read the note number K in K hours. The order doesn't matter. And yeah, so he can choose any notes. So he has to spend at most 8 hours in total and fully read several lecture notes tomorrow, spending at most B hours in total. I still don't understand what is the difference between A and B. Okay, so A is the number of hours today and B is the number of hours tomorrow. Okay, now I get it. Okay, so we are just given two integers, A and B. For example, here we can see 9 hours today and 12 hours tomorrow. And we have to choose some integers from 1 to like, whatever we want, distinct integers, so their sum on each day doesn't exceed our given value A or B in first and second day. And we want to, what? I guess maximize the total number of read nodes. Yeah, what is the maximum number of nodes Leszek can read? Okay. So, what to think here? Well, it doesn't make sense to spend time on very big integers. Here in the input, we will not use very big integers, for example 1 million, because instead it's better to use more, to read more of smaller nodes, smaller integers. Okay, so my claim is that those numbers will be up to square root of 10 power 9. Because when you add 1 plus 2 plus 3 plus and so on plus n, then this sum will be roughly n squared. So if this sum should be something of order 10 power 9, then this n must be something like square root of n. It can be bigger. So first observations in problems where you have to add different integers and their sum is something, there will be at most square root of billion of them. Okay, and if there was only one day with one given integer a, then the solution would be just to greedily take node with 1 hour, then 2 hours, 3 hours, and so on. It doesn't make sense to use a bigger number of hours for a node. So we would just greedily add nodes one by one and see when we exceed the given a. But here, of course, task is a bit harder because we are given a and b. And it would be hard to do any dynamic programming because a and b are 1 billion, so we can't have 1 billion as a dimension in dynamic programming. We likely want to have something like square root of that in complexity, and then it will be okay. Okay, so let me create a file for that. I still don't know what to code exactly, but maybe coding a little bit will help me come up with a solution. So when we have that a and b, what we can consider is the sum of a and b, s. So this is the total number of hours we can use. So some upper limit for the answer can be found just by considering this s. If we, let's say that I is first one, so this is the next node to read, and while used hours is the number of hours we already spent, while used plus I is not greater than s, increased, so use this node with I hours. Use it increased by I and I plus plus. So here we can print I to see if indeed it would be something like square root. So this is just a greedy algorithm for one value, for like one total limit. And so let's say that it's 1000 and 1000, then we can, so in total we have 2000 hours, and our program said 33 is the number of nodes we can read. What about 1 billion and 1 billion? It's something like 60,000. So it's okay. It's roughly square root. And what now? Well, it would be best to achieve exactly this result. But maybe it won't be possible. So let's think when would be not possible. So we know that you want to distribute some numbers, for example 1 through 7, because given as the total number of hours is okay, it's not smaller than the sum of these numbers. And now we want to distribute these numbers between 2 days, such that one day will be up to A and the other day will be up to B. So maybe sometimes it would be impossible. For example, if the numbers we want to distribute are, let's say, 4, 6, and 10, and we have A equal to 13 and B equal to 17, so 7, then theoretically the sum of those is 20, so we can fit numbers 4, 6, 10, but it's impossible here to distribute numbers into 2 sets of numbers. So by the way, you might think about it as kind of a modified knapsack problem. So like the kind of requirement to be good in problems like this is to know knapsack dynamic programming. Okay, but here we have very special case. So generally we couldn't implement knapsack because the complexity would be 1 billion times n, I think, times 1 billion times the number of items here, so 1 billion times square root of 1 billion, so too much. But here we have very specific case. We have numbers 1 through something. And with that, it's actually possible, I think, to put them into any sets of required sizes, because we have these small numbers that are very flexible. So what the solution is, and it actually comes from seeing similar problems, then it's easier to notice something like this, is that so it's a bad idea to go from left to right and decide which number goes to which set. So we want to create a set with sum A and create a set with sum B. It's a bad idea to decide, okay, this goes to the left set, right set, and something like that, because at the end it will be hard to distribute numbers, to finish, to get exactly A and B. Like possibly, because if the sum of these numbers is exactly A plus B, then we must exactly A in the first day and exactly B in the second day. Well, of course the statement says at most A and at most B, but in some cases we will have to get exactly that, so we can't make a mistake even by 1. So as I said, it's easier to see it when you saw a few similar problems. It's better to go from right to left, from big numbers to smaller ones. Generally, if you want to write some heuristic for knapsack, some greedy heuristic, some good approaches go from items with big values, big weights, because then with those smaller items you can easier get exactly some total value or total weight. So actually we go from right to left, and we want to get A and B, and just with any next item, if we can put it in the left map, if in the left set we put it there, otherwise in the right one. And what I claim is that at any moment when we distributed some numbers already, so still there in total there must be a place for these 3 numbers. So in total what is left, what place is left in left and right knapsack set is in total 6, 1 plus 2 plus 3. So for sure one of them must have a place for a 3. So generally, if we, for example, if we considered everything up to this point from the right, then we know that the remaining place, total place in sets is 1 plus 2 plus 3 plus 4 is equal to 10. So for sure in one of them there must be at least 5 empty space. So we can put this 4 somewhere. And this way we can prove that at any point when we go from right to left, we can put it in at least one set. So we want to prove that for any remaining sum, remaining items with small weights 1, 2 and so on up to k. So this is equal to k times k plus 1 divided by 2. So here we are doing something that isn't needed, by the way, for the implementation. We are proving the correctness. And what I claim is that so this is what is this total remaining space in two sets. And what I want to say is that then at least one set contains k times k plus 1 divided by 4. Contains meaning has space, something like this, empty space, because, well, if the total remaining space is 20, then one of them must have at least 10. And now the claim is that this is greater than k, because we want to say that for these remaining items we can put the biggest of them in one of sets. And for big k it's obvious that this is true. For example, for k equal to, I don't know, 100, then this is 100 times 100 greater equal something. So we just want to check small k values, and you can see that for k equal to 1 it wouldn't be true, because it would be 1 times 1 plus 1 divided by 4 is greater equal 4. So our claim isn't correct. But actually, if this is total remaining space, then what we can see is that at least one set has space sale of that. So the floor is taking the removing the non-integer part, and sale is rounding up. For example, instead of 3.7 we would have 4. So this is sale function. And our claim is that this, so because if both sets has smaller than that, then the total space will be smaller than this. And the idea is that, for example, if you say that the total remaining space is 7, then at least one set has total remaining space 4, because it must be distributed 3, 4, or even less evenly. And I claim that this is correct, and you can check that for small values k. So for k equal to 1, now we have something like this, and now it's true. And also for 2, it would be 2 times 3 divided by 4 is greater or equal to 2. It wouldn't be true without this sale function, but with this it is true. And you can check that up to 4 or something, and then for biggest values it must be correct, because this value is greater than 1, so then k must be greater or equal k. So this was formal proof. You don't need to do it during a contest, but it's so you'd see how to prove it formal. It's better way during a contest to just think that, okay, so here we have the remaining space 10, so yeah, in some set there must be space for this number. Then the same here, and so on. And let's implement that. So actually we used k in below, so let's change it to k. And now we have numbers from 1 to k, and we want to distribute them. And we want to, okay, so let's say, well, let's iterate with I from last element to the first, so from k to 1. And if I fits in the first set, then we put it there, else we put it in the second set. We can put an assert that b is equal, can indeed fit I, and now we will print something. So let me also gather the numbers into sets. So here to A we push back I, here we push back I to B, and now what remains is to print them. So I wonder if we have to sort those numbers. Sometimes if you have to if you have to print a set of distinct numbers, sometimes the statement says that they must be sorted, but here we see that it doesn't have to. Okay, and instead of just implementing the same code twice here to print A and print B, let me create a function for that. So print set A and print set B. So we have to print the size and print numbers. Sorry, I wanted to stick with this easier to read version. I think that couts are easier to read, especially for people not familiar with C++. So let me change that. Remember that in general you should avoid using here EMDL because it's slower than \n. So try to use this. The difference is that EMDL flashes the output, what is slow. Let's compile. So I don't want to even copy inputs because they are very small, and free assertion failed, so something is wrong. So let's here with CRR print K. Hi Predium, thanks for the proof, says Ronadiv. Yeah, somebody suggested me the previous time to often give proofs, and I think it's a very important lesson. Even not really to show you how a proof looks like, but how to get to a proof. Okay, so here K is equal to 4. Is it okay? I think it's not okay. Because the sum is 6, so you can't fit 1, 2, 3, 4 in 6. So something is wrong. What is it? Okay, we said while used plus K fits in S, we use K, but then we increase K by 1. And the last K we will not use. We can analyze a smaller example. If S is equal to 3, then first for 1 we have this condition is true, so we do used plus equal 1, so used becomes 1, and now K equals 2. Then in the second run of a while loop, we also see that this fits, so then we add K equal to 2, so used becomes 3 and K becomes 3. And now we see that this condition isn't true anymore. So actually K here, after this increasing by 1, denotes the next number we could take. So I think here we should decrease K by 1. K is now equal to 3 indeed, and we printed a division into sets single integer 3 and 2 and 1. Okay, seems fine. And let's run it for the second sample, 9, 12, and we got 6 numbers. I think it's the same numbers that are printed here in the sample out. Awesome. We can also run it for the max test to see if it's fast. And yeah, it's fast, and it printed something. So it's hard to say if it's okay. We can, to see if it makes sense, we can run it for some smaller sample. And here it makes sense that like something like 19 big numbers can be equal to 43 bigger numbers. So this is what I would expect, and we can submit a problem. if something was wrong, so for example, if we get wrong answer here, what I would recommend here is adding some asserts to code. So here I would say, let's say, I would check if A contains distinct elements. Hooray, we got accepted. Still, if we get wrong answer, or if we just implement a solution and we want to check if for sure it's okay, then for example we can check if A contains distinct elements, so sort, and then iterate over pairs of adjacent elements, and assert that the two adjacent elements aren't equal. And now if you submit that again, or if you just run this for some input, you will get runtime error. This assert will fail if this is not true. So you will know if, and also if you submit, you will see runtime error. So this way you will see if this is a reason of your wrong answer, or maybe you should try to find a different reason. Also, what we could do is we could, for example, count the sum of numbers in the set and compare it with the initial A and B values, and assert that this doesn't exceed those values. If it doesn't, then you should maybe try to think if for sure you are finding an optimal solution. Interesting. Can you win anything? Just curious. Also, I like competitions where the point of the problem is solving it. No. So in Codeforces regular rounds, you can't win anything. Well, you're fighting for your rating, something like ELO. But from time to time, there are competitions with money. So last time I won something was in Google Code Jam finals, and it was like $2,000 for the second place. While for the first place, Gennady got $15,000, I think. So, but it's hard to win, of course. So sometimes there are prizes, and also you travel a lot along, like in the world. Like 2 weeks from now, I'm going to USA because of that, for free, because there is a competition there. It's better to pass const vector int %a to print set. It's a good point. If you care about the running time, then here it's better to pass a reference to A. Well, here we can do it because we sort. Const in C++ means you can't change that, but also we can pass it, just add ampersand to make it a reference. And the difference is that without this, what program does, it takes this vector of numbers and copies it, creates a copy and gives to this function. While right now, this function uses the same vector. And yeah, you should do this if you care about time. For sure, it isn't needed here if the sizes are like tens of thousands. It only can matter if it's an important thing in your complexity, or you're worried about the running time. And if you don't need it, I would suggest to either not give reference, or if you're giving a reference, then also put const, because if you aren't sure what your function does, you will modify it later, you have a risk that you will modify it and you will forget about it here in the main function. You don't want to here modify a vector and here forget about it. It's good if functions are kind of black box that don't affect the outside world. Okay, and if you have any questions, of course, ask me. And if not, we will move to the second problem. Once again, professional change. This small box with text seems, I think, it's working, I hope, and it will be easier later to to find a problem that we want to go back to. So let me again write a template. And problem B, so it should be slightly harder. We are given, actually I've read this problem yesterday and I quite like it. And by the way, I had some part in maybe working on that problem when I was in internship in IMTech. So we thought about a similar problem, a problem like this for IMTech round that took place like 1 month ago or maybe 2 months ago. You're given a square matrix n times n filled with lowercase English letters. You can change no more than k letters in the matrix. So you're given matrix n times n and also an extra integer k. And consider all paths from left top corner to bottom right corner. Where we want to go each time right or down. For example, A, B, C, 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 D, E. So each such path has length 2n-1. Find the lexicographically small string that can be associated with a path after changing letters in the most k cells of the matrix. So we want to find some path after changing k letters. And of course, since we want like lexicographically smallest string, it only makes sense to change letters to A, because to minimize something, to minimize the string. And also it doesn't give us anything to change letters from outside the path. So if our output path will come from this path, A, B, C, 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 D, E, then the only thing that makes sense is to change some letters here to A. And of course, for lexicographically smallest strings, we should just change first letters. So first here, if we want this string, A, B, C, 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 D, E, and k is equal to 2, we'll just change 2 first letters to A. But the string that I proposed isn't optimal, because we see in the output that the optimal one is AAA and then B. While here I proposed AAA C, and I think this optimal output here comes from the path that goes just first column and then last row. So A, here we change A, B, C, D, E, and this is output. In other samples we also see that some first letters are A. Of course, let's remember that it doesn't mean that all these letters were changed, so that the number of letters A here is just K, because some numbers could already be A, some letters. For example, here, the first letter is A already, so we don't have to change it. Change 1, 2, and 1, 3 to A. Yeah, exactly. These two letters. Okay. If we are given a string, so if we just are given one row and we want to minimize it, then greedy approach will work. We'll just move from left to right, and if something is not A, then change it to A, because for lexicographical order, the most important thing is first letter. It should be A. If we already have some letter there, and we can't change it to something smaller, we should focus on making the second letter to be A, and so on. So then we would just change some prefix to A's. We could change up to K letters that are not A to be A. And it's good to say, to note that letters that are far away, for example, we are given a huge string and K is small, then we don't care about those letters in the suffix. We just care about making as many letters in the prefix to be A as possible. So if for a single string a greedy approach from left to right works, then maybe we should think about something similar here when we are given a grid. And so we said already that we want to have as long as possible prefix of letters A. So let's focus just on that. how big prefix of a's can we have? Here it would be 3. Well, we'll have to start from top left corner, and similarly to some, you can either think about it as dynamic programming or about, I would say, BFS. If you watched my stream yesterday about writing an AI bot, you will see some similarities. But what we want to do is we want to move from this top left corner, and for every cell then we want to say how cheap we can get there. So maybe let's talk about a wrong approach that I can analyze here. If we have something, if we have a grid like this, and for example here we see A, and we move from top left corner, it isn't correct to greedily go to A that we see in adjacent cell. Why? Because maybe further there will be more A's, for example in these two places, and then if k is equal to 2, for sure then we will change this D to A. We must make the first letter to be A, so now k is equal to 1. And right now, if you from this cell go below, if you go down, then you only have one more possibility to change a letter to A. So it will be this one or this one, and that will be it. You can't get more A's. But if from here you first change this letter to A, you get 2 more A's for free. So it's better to change this letter. So while we said that we will try some greedy algorithm in terms of changing some first letters to A, it isn't correct to say that in the grid we can move greedily. Okay, so instead, as I said, either you should think about it as dynamic programming or as BFS, that we go from here, so we move towards the destination. If we can go just right or down, a good order to consider cells is to just go diagonal by diagonal. So first consider A, then S and A, D, E, and so on. Okay, and for every cell, what we will want to know is, can we get all A's up to this point? And if yes, then what we want to minimize or maximize? Well, we want to use as few as possible changes so far. We want to maximize the remaining k. So let's start with that. Of course, this is not a whole solution. Let's read the input. If you want read with sin and print with cout, you must do something like this to make it faster in C++. Or you can just use scanf, then you don't have to write these two magical lines, but this is harder to read, as I said. So I will stick to using sin and cout, but it adds these 2 extra lines that you have to write at the beginning, if the input can be big. And it can be big in this problem, because matrix of size 2000 times 2000 is something of magnitude millions. So you must read it in a fast way. Okay, so let's create a 2-dimensional array that represents a grid. Now, row by row, we read it. This line reads one string, so one row. And now what we can do is we can access grid of row column in this order. So not in like some math problems where you say that x coordinate is to the right and y coordinate is to like up. Usually in informatics, in like screens, monitor, grids, we go from left top corner. This is something that is printed first. So we go in this direction. Which is the best book to learn algorithms and data structures in 2-3 months? If you start, I think you should, I recommend this PDF because it's quite modern. It's called Competitive Programmer's Handbook. I've read Corman book that is very well known, and I think it has too many proofs, it's too mathy, it's too hard to read, it isn't that modern. Just check for closest A in reach of K, furthest A. Something like this will also be wrong, I think. If you want to do something like this, find smallest something, find furthest something, you must think about its correctness carefully. I'm not sure if I understood correctly, but do I have glitches now? I've just seen some on laptop. Do glitches happen right now during a stream? So back to the problem. If you start from somewhere, and then you're just going to look at the closest A or furthest A that you can reach, I think it's a wrong approach, because it doesn't consider, for example, what A's are there like further from you. Well, it would be good to say find the furthest A that you can reach with K changes, but this is exactly what we are going to do here with this BFS/dynamic programming. It isn't that easy to implement, to find the furthest A that you can reach. But yes, finding the furthest A that we can reach with K changes is exactly finding the longest prefix of A's. What if we change as much cells to A within range of K and then start doing BFS for smallest lexical string? Okay, but you don't know what cells to change to make it optimal. For example, here it's optimal to change this cell to A, and then you get 4 A's. But you don't know what cells to change. If K is just 0, then a problem is easier. We can talk about it in a moment. Because now a problem is just find a string that is smallest lexicographically, so you just move with A's as far away as possible, not necessarily greedily, because you don't know after some A if you will get a new A. But when K is positive, you don't know what cells to change. Okay? So, for every cell, we can make a DP for storing the remaining K for any cell. This is what we're exactly going to do. Pradium. So DP of row call will denote. So what it says, it is the minimum number of changes we need so far. Order to get to cell row call with only A's. This is the definition of dynamic programming. If you aren't very experienced with dynamic programming, I strongly recommend saying to yourself what is the definition. Because if you write down something like this, or at least you say that in your mind, the implementation can be easier for you, because you will understand what to do. So DP of, this was the definition of DP of row call. So now dp of 0, 0 is, let's say, 0, but if this cell is different than 1, then we say that it's 1. Also, let's mark all the remaining cells as infinity, or maybe we will not do that. dp of row call is infinity. So this is 1 billion plus 5. When you test your solutions with brute force, do you test them in the same source code file or to executables with a shell script? It's an important question that actually is hard to answer. I see advantages of both. Let me finish with this problem and then I will answer. Okay, and now going through all the cells, and I said at some moment that we go diagonal by diagonal, but so then this one and so on, but actually going by cells in just direction order row by row is also fine. What we want to say, for example, let's say we will first consider this row, then part of this row, and I'm saying it's okay because when you consider a cell, you already considered both cells from which you could get to this cell. It's important that what is important when you consider some order is that if you go from this cell, you can go from this cell to this cell. So what is important that for sure you must consider this cell with F first, and this order guarantees that. So if row is not the last row, then we consider it going down. So dp of row plus 1 call is minimum of itself, and so let me put it a bit above, not to make my my picture, my face, cover it. And dp of row call. Okay, here actually, so sometimes we must add 1 here. We must add 1 when this new cell is different than A. So different than A. Yeah. So this expression will be dp of row call, so the current value, plus 1 if this is different than A. So an expression like this in C++ is 0 or 1. But if we have this approach, then the code will become quite ugly, I would say, because here we need the same for moving to the next column, so moving right. And I don't like that because it's easier to make a mistake. And actually, so there are two ways usually to write a dynamic programming like that. Either for a cell you consider going from it to the next cell to the right and down, and you update answers in those two, or when you're considering a cell, you want to then compute its score, its distance from the beginning, and then you consider two previous cells. And this is what will turn out to be easier now. So you can finish with this approach. It's correct, unless I made some typo, but it will be easier to, instead of move to the next row here, just to take answer from the previous cell. So if row is different than 0, so if it's not the first row, then dp of row call, so my value is minimum of itself and the previous row. dp of row call is minimum of itself and previous column, so moving from left. And now also if grid of row call different than A, plus plus my value. Okay. One more thing that I would do it differently here is that I like to create a function that takes minimum of value and some other value, and you must write it this way with reference here. Here a is equal to minimum of ab, and then you get a simpler code where you don't have to reuse the same value, because it's bad that I printed dp row call twice, because then maybe I will see that I made a mistake, I want to change it, and I will forget to change it in one of the places. So it's better to just use mini. And similarly, I would implement maxi if I need it. Also, sometimes I call it min self. If you go through my codes, for example, submissions in Codeforces, sometimes I call it mini, sometimes I call it min self, because it minimizes some value, it updates this value, self. Okay, so mini is okay. Okay, the disadvantage of mini is that it's similar to min when you read the code. You can mistake and implement and write min instead of mini, or the other way around. So this is why min self is maybe safer, because you see what it does for sure. But I will stick to mini. And what now? Well, let's run it on samples and let's see what values are printed. Also, one more thing, since I also consider cell 0, 0. So when I have these two loops over all the cells in the grid, I also consider cell 0, 0, and I wonder whether I made this if correctly, because I changed my approach later here. So actually for 0, 0, none of this will happen, but now if it's not a, then I will increase the value by 1. I don't want that, so I think I should just remove this part, and now it should be okay, I think. But it's also something that I would see from, if I didn't notice that, I would see it by now printing what values I have for the sample test. Okay, now let's copy the sample test. Okay, maybe also the second one. So, here for the first sample test, I expect value here to be 0 because it's a, and I expect all the values increased by 1, except for this place where we have an a, and indeed it didn't increase by 1. Wake, I think, causes some glitches, so let me use pop-on terminal. Okay, so here I have an a, and indeed value here is the same as up and to the left. So I think the values are okay. I can also take a quick look at the second test. And here the first value is 1, as I expect. It's important to check this kind of corner case, what happens in this cell 0, 0. And here I have an A. And indeed, I see that my program understands that he can go from this cell to this cell with no extra cost. So for every cell, I computed what I wanted, so we have a definition here, the minimum number of changes so far in order to get to this cell, to use just A. So now, and so far we didn't consider k at all, we ignored the value of k. After we found the prefix it is just moving to the lexicographically smallest adjacent character right. You're almost correct. So you're right if all the characters in the grid are different. Because then if you have two different characters to choose from, then of course we should choose the smaller one. This is what works greedily for lexicographically smallest string. But we can have ties, and this is a bad thing. So now we basically, let's focus on case with k equal to 0. And let's say that there are no a's. Okay, right now from this place you can go from z, you can go to s right and s below. And if one of these values would be different, then you can greedily choose between s and w. But if they are the same, it's also important what happens next. In this case, from z, you must move to c, because then you get b. Sorry, not to c, to s. Because then you have a third smaller character. So here the prefix of optimal solution will be zsb, and it's only possible if you choose this one. So if we care about lexicographically small string, we should care about ties and what happens next. Okay. So what to do here? Actually, we don't have to greedily choose. We would have to if we, for example, had to get complexity O of n, so the side of matrix. But it's okay for us to have O of n squared in the complexity to consider the whole matrix. And from this place, we actually don't need to make a choice whether we want to go right or down. We just want to say, okay, we can be here, we can be here. Maybe then we get an extra tie, more complicated tie, because maybe, let's say, so second letter can be here or here, third letter will be here and here, and only the fourth letter will decide. So what we will do is we will maintain a set of places where we can be. Of course, we know the letter because so if we know that this is a second letter, the third one is the smallest adjacent letter, but there could be many places with that letter, and just all of them are possible candidates. Would you stream on Google CodeGen problems sometimes? They have quite good editorials, and I don't find them much better than other problems to stream. I think that Polish National Olympiad in Informatics is better because there are no editorials in English. But I might stream CodeGen one day. But of course here we had some bigger k. And with this dynamic, what we can do is to know that biggest possible prefix of a's, and this tells us some possible place where we can be after this prefix, and from that place we'll run this algorithm where we can go to smallest adjacent possible letter, but we maintain a set of places where we can be. And I think that now we have to go diagonal by diagonal. Okay, so we can comment this. So this was printing the integers, the grid. So let pref denote the size of prefix with a's. I'm not sure exactly how to implement it in the best way, but some approach will be to now iterate over cells. And if dp of this cell doesn't exceed k, then prefix we maximize with the number of diagonal of this cell, and this will be this number. And so let me create a function maxi, similarly to mini. During contests, the typing speed is important, so it's okay to have these two functions pre-written. Okay. And let's print the size. It's 3 for first input and 3 for second input, and it's okay here. It's indeed 3 letters A. Let's also copy the last input. I see glitches anyway, so I can use Quake actually. It's 7. Let's count them here. 3, 6, 7. Okay. Let me minimize and go back with this. Maybe it will remove glitches. I'm quite frustrated about it. The memory isn't an issue, CPU power isn't an issue. I don't want to restart OBS because then stream would stop and then the video later in YouTube would be split into 2 parts. What I can do? I can close Chrome and open it again. Oh no. Oh, so chat is loading now. And I see the history of everything that was written so far. Interesting feature. Okay, so the size of prefix we found was okay. And now we know that we want to get to this place with this prefix. How do you copy to clipboard and paste it in Bash using in3? Well, there is a button here to copy, so it's equivalent to like choosing this area and hitting Ctrl+C. Then cat prints the file, and I redirect it to some file. And then shortcut Ctrl+Shift+V. In Windows it would be just Ctrl+V. Pastes what I copied. Okay. So now actually instead of pref, so let's create our string. This will be answer. So we put this many letters A here. At the end we will print string. Okay. Here it will. Let's create a list of cells that are candidates for the last cell so far. Let's call it a list. And now let's just go through all the cells again. And if this cell was accessible, and the diagonal number is pref, just not to think that we can finish in some of the first cells, we append it to the list. Okay, let's print those numbers in some input, some sample input. So in the first input it said that they can be cells 0, 2, 1, 1, 2, 0. So this cell, this cell, this cell, it's okay. In the second it's also trivial. Let me actually copy the first sample and modify it a little bit. So instead of a here, let's create a here, and now I expect that only these two cells are optimal. And yeah, now it's printed 1, 1 and 2, 0. So this cell and this cell, it's okay. During a contest, I wouldn't test it so much while implementing, because time matters, and if I feel quite confident in implementing this problem, if it's quite easy for me, then sometimes everything will run smoothly the first time. But for harder problems, I do what I now show, that I test it part by part. Okay, we can comment that. I recommend commenting instead of removing, because maybe you will need it later. And now current diagonal is just prefix, and while diagonal is different from the last one, so this formula row plus col plus 1 for last cell will be n minus 1 plus n minus 1 plus 1. Here we want to go to the next diagonal. Let's find best character that we can go to. And now for cells in our current list, we'll consider going right and down. So this is an alternative way of writing for dx0 up to 2 up to 1. So this is the same, just shorter version in C++. dy is, so, well, this is delta row, and delta col will be 1 minus that. If this cell is inside, then we minimize best char with this new cell. And right now we can't change we can't change more cells, so we just consider this cell. So row 2 is row plus d row, C2 is col plus d col, R2 C2, R2 C2. And I expect that now I know best possible character, so I will do, to answer, I will append this character. And now a new list. I want to create those new cells that are exactly equal to that. So actually I will here also gather new list. And here instead of mini I will write if grid R2 C2 is smaller equal best char is that, and new list append this cell. There are quite a few ways to implement this. At the end I will do list is new list. So I expect moving diagonal by diagonal. For example, if I know that these two cells are optimal so far, then maybe I will go to these two cells. And one more thing is that this list should only contain cells that are optimal. So actually, if grid of R2 C2 is smaller than best char, then cells that I gathered already should be removed. So new list clear. And I think now we are okay. Some compilation errors. Row is not declared because it should be p first and p second. We don't have a function inside. Let's create it here when This could be of course an outside function, but I have n here, so I can do it with auto function like lambda in C++. And the last thing, append is of course pushback. And we can run it on sample test, and it works forever. Likely because here I have this condition. Well, if something works forever, I always take a look at my condition in while loop, so I never change diagonal. So here I must increase it by 1. A, B, C, D, E, it's okay. Second one, F, A, F, W, it's okay. Third one also looks okay. You can use in place back like list pushback row call to have the constructor card with the arguments instead of make per, works with any type. Thanks, Bluefog. Yeah, so my ACM teammate always tells me that. Also, it's faster because I think what I do here is I create a new instance of per. In place back is faster. So instead of that, I could write in place back to C2. But it's for some reason very hard for me to switch to in place back. I'm very used to pushback. Let's see if it's okay still. Yeah. What I actually do during a contest is I don't write make per. I write it with these brackets, and it works in modern C++. So it isn't really like longer to write that in place back, and I'm just used to pushback because this is how I learned, and it's hard for me to switch. But yeah, I agree with you that it's better to use in place back. Can we make requests for next problems? We can, but the difficulty should be something around div1b, and since this stream is about Codeforces problems, it should be a Codeforces problem. Yes, in place construction, yeah. So I recommend doing what Bluefog suggested, using in place back. Also, I will try to I wanted to say I will try to use it from now on. The disadvantage is that it's harder to read for those who don't know C++, maybe. Like the construction, also why I print here make per is I want to make it easier to read, because not everybody know what these brackets do. So in place back is maybe a bit hard to understand because it takes two numbers for some reason. But for good C++, yeah, I recommend in place back. Let's submit. Also, I see right now that I print something unnecessary here, a 7, instead of just a string. So I would get wrong answer here. So let me remove that. It's better to print with CERR, because then I can leave it. Also, I can redirect this redirects the error output to see what is my standard output, and it's okay. And as long as you don't print a lot of stuff with CERR, you're good. But if you print a lot of that, it will also be printed in background when you submit a problem, and the issue is that you will get time limit exceeded. 196b. I got wrong answer. So, because it's quite hard to test this problem, I'm just going to look at issue. I printed a lot of this for some reason. Well, this is not at all the beginning. And it's a test with k equal to 0. So maybe something is wrong when k is equal to 0. Yeah, something is definitely wrong. Because here I also printed just this. So Indeed, if k is equal to 0 and the first character is not a character in cell 0, 0, then nothing will be here added to the initial list. So what I should write is, I think, if list empty so pref will be equal to 0 here, what is okay. So let's to list, well, in place back 0, 0. And I wonder if then this condition will be correct. And it's incorrect because it printed one extra z. Actually, I think that, well, not z, z, right? I think that this condition is stupid. Anyway, here I should write it not, if not list empty, and not care about this diagonal, because just while there are some new cells to consider, it will do something. Okay, so here if new list empty, then break. I think this will be okay. Of course, this an issue like this is just something random that you can encounter, and it isn't worth explaining a lot for me now what and why I'm changing. This is just some bug, and of course I cheated a bit because I saw as a test for which I'm wrong, so still it's wrong answer. But well, still I anyway see that I already see that we take a lot of time for every problem, so I want to avoid that. Okay, the first letter is wrong, so maybe it was also wrong here. Yeah, it was wrong here because I skipped the very first letter. If list empty, I also want to answer at grid of 0, 0. So just something random that you wouldn't get if you just implement something slightly different. And Z and Z is both correct, just different origins. Okay. Memory limit exceeded. What is the memory limit in this problem? 200 megabytes. Okay, I think I understand the issue. Let me try to freeze my computer. Maybe it isn't a good idea. Let me freeze ID1. So I think that if I make all cells to be equal, for example, equal to B, whatever, okay, run, and now as input let me say it will be, for starters, 30 and 0. So I just here put N and K, and I made all characters to be B. Let's see the running time. And it's already time limit exceeded. Let me change this to 15. I think I wrote something with exponential solution. I wrote exponential solution. And yeah, for n equal to 15, it took 2.5 seconds, and it took already 67 megabytes. I didn't want to run it on my computer, worried that maybe something will go wrong and all the memory will crash, and like I will have to restart. So what is an issue? Well, when I create a new list, I might put some cell twice, going from up and from the left. and then this thing stays there twice. So it's better either to use set here, or at the end when I have some new list, just remove repeated pairs. So how I do it is I sort it. Sorry, so here we already made this. So sort list, remove repetitions from list. And now list resize. This is some complicated thing in C++. There are also different ways. I always resize to unique. Unique takes some interval, removes occurrences, repeated occurrences of adjacent numbers, and returns pointer to the last element after that. Something is wrong. So I didn't do it correctly. Okay, minus list begin. This is new size. So let me submit again, and I hope this time we will get AC. So here, when you get something like this, we would see it on samples, sorry, on pretests. Also, when you don't see that and just before submitting you want to test, it's good to run a max test. And in this case, you would see that something is wrong. Either it would run forever, or memory would crash. Okay, accepted. You had the same entry twice, maybe. Yeah, you're right, Anti. Thanks. Please do this. DP over 1,000 people solved. So you mean problem suggested by Alexei, or what? Please do 1030E. A lot of people solve it. Okay. I'd like to see 1039A. It's div1A, and still don't know how to solve it. Okay, I will open a few problems and we'll just have a vote. So one suggestion by me is to take problem C from the same round. It's a constructive problem, and so it's also a problem from around from yesterday. It's also a problem from around yesterday, and editorial explains some solution with cases, and I don't want to implement that because it looks boring. What I want to show is how to get those cases, how I myself thought about this problem when solving it unofficially. So I would show you my notes, show you my thought process. So this is one possibility, and let's see yours. So 196B. I don't know a better way to find a contest than search like that. I can try to change a browser, or maybe minimize it, decrease it, to get rid of glitches. I can close this. So it was I lost it. 196. Later. (196) B. Book of Evil. Please confirm that I found a correct problem. It looks like what? Like a problem on a tree? Okay, so this is also some possibility. I can replace ID of a problem, right? Not of a contest. Oh, here I have, no. So this ID doesn't match what you gave me. So, because this counts contests. Oh, okay, so this didn't mean problem V from this round. Okay. So it's infinite maze. So looks like something on a grid, maybe a bit similar to our previous problem, and glitches still happen. I'm very sorry for that. Okay, this will be the other possibility, and the last possibility, let's say this one. So this was something that took people sometimes half an hour, sometimes 10 minutes. So it's, I would say, maybe slightly too hard, but it's some possibility. Did I close it? So something with sequences, binary sequences. Let's create a poll. I don't want to try to create a new like poll with some website, so let's just see. Let's create it here. So one, it will be see from yesterday cases. Two, it will be infinite maze. And three, it will be binary sequences. So just type 1, 2, or 3. Also, I was supposed to answer some question, now I remember. How do I test, whether in a different program or the same one? So, especially in my team during ACM trainings, I was always the one to test programs, because I prepared a lot of problems in the past, so I write generators, brute forces, I think, very fast, and I think I test it well. I can test it well. Usually I create a separate program. I call it brute force CPP, something like that, and I test it with a line in bash, something like this. Also, I create a file for generator. I will paste it here. So generator as the first argument should get seed, and advantage of that is that you can't make a mistake because of multiple test cases and, like, I don't know, static values, something not initialized correctly, stuff like that. Disadvantage is that it's slower when you want to run many thousands of tests, because for system to run a program, it takes like 1 millisecond or something. So actually, even if your program works in a small part of millisecond, if the complexity is very small, if, for example, just you want to test for n up to 5 and the complexity of brute force is n squared, then with this method you will only be able to test like 1000 tests in 5 seconds, something like that. So in 1 minute, 10,000 tests. While if you put it in one program, then you are able to do like 10 times that. But prefer this way to make it maybe slower to test, but to be more sure about the correctness. Okay, we have... okay, let me count by hand. So again, professional team. 1, 1, 1, 3 votes for 1. Also, let me see if somebody voted twice. 2, 2, 2, 2. Okay, I think we have number 2 won. So let's do that. Infinite maze. Infinite maze. Also, I will create a problem, and then if I really don't like it, I will decide that I'm not going to do it if it seems boring. But we can try. So it's from round 1 to 4, it's a problem B. And let me open a new browser to see if we'll get all the issues there. So for starters, let me just... I'm not closing Chromium or Chrome, and I want to see if now there are glitches. It's a bit also it's a bit hard to check because there is some delay, like 15 or maybe even 20 seconds, and when I do something and when I want to on my second screen see if it works, I must wait a little bit. But for now I see no glitches. So maybe just about my browser. I also will have to log in everywhere. It is important now. Okay. We are given a rectangular maze. We are given a rectangular maze. Each cell is blocked or empty. And somebody took this maze and repeated it many times. So infinite number of times. So for example, if we take this, then we copy it and put it to the right, and also below, and so on, infinite grid. He stood at some cell on the plane and he wondered whether he can walk infinitely far away from his starting position. And from a cell he can go to one of 4 adjacent cells, but of course he can't enter cells with walls. So we are given a grid. He's in one of cells, denoted as S, and I assume that after he leaves this cell, it's an empty cell, not a cell with a wall. And here we see that if we copy this cell below, then he can go here, and from this cell he will go to this cell. So indeed he can go infinitely, and here he can't. So for example, this cell is connected to this cell in the next occurrence of this pattern, but it's a dead end here. Okay, problem looks cool, so we can solve it. How to start? Well, I think now some drawings will be useful. So how to do it? Okay. So in a moment I will make it slightly bigger. we have something like this for starters, and let me make it bigger. I don't see a shortcut for that. Just plus. Okay, the quality isn't the best, but we can work with that. Okay. So this is a border between two occurrences, and we have a pattern like this repeated infinite amount of times, and we want to know if, so for sure we can check what cells are connected between two consecutive occurrences. So by seeing that this cell is next to this cell and they are both empty, we know that from this cell we can go to this cell. And but it isn't everything. We don't ask if we can go for some time in some direction. What we can ask is, what we want to find out is whether from the starting cell we can get as far away as, not as possible. We can go at any distance from this cell. For example, if we want to go to be at distance 1 billion, we can. If yes, then we print yes to the output. Of course, he starts at some position, and other cells I think we should imagine to be empty. Okay. And just we wonder from this cell where we can go. Well, here of course, if we copy this pattern more times below, we can see that we can go along this path infinitely long, but things can be much more complicated. Some idea is to check whether from some cell in the last row of our pattern we want to know if we can go to the corresponding cell in the top row, and from this top row if we can go along, so in the pattern again to this cell below, then it's kind of an infinite loop when we can go down and down and down. But it isn't enough to just check in this grid if we can go from here to here. Let me try to create an example for that. How to do it best? Okay, let's see. Let's say that we have something like this, and let me create 2 more rows. If we start from this cell, and the cells that I mark right now are empty, then from this top cell we can't go to the cell in the last row. We can't reach it. But if pattern looks like this, so repeated to the right, so with I don't know, with green let's mark repeated pattern. Now here are also empty cells, those accessible ones, copied from here, and actually we can go along this path infinitely long. So it shows that it isn't enough to just consider going from top row to last row in one pattern, in one occurrence. I think that also it's not enough to consider going like if we copy it 2 times or even like I don't know, 9 times around the initial pattern. I think it still will be not enough, because maybe there will be some complicated pattern where you can go, I don't know, something like this. Then from here you can go here, so repeated it would be here. Then from here you can go here, so it would be here. Hard to say. So I'm still not seeing solution. But what I think will be important is to focus on first column, first row, last column, last row, and inside the grid, if we run some DFSs and we know between what cells in this border columns and rows we can go between, then we don't care anymore about the middle of the grid. We will just know inside the grid that between these 2 cells we can go somehow through the middle. So we can assume that we can teleport between them. Okay, and then we only consider this frame. And what might be useful is that there are only O of n. So let's say that the given grid is square and the side is n. Well, we have n square cells in the whole grid. We only have O of n cells in borders, and only those are interesting. So I think in n square we will run some DFSs first to know which cells are connected to each other in the frame, between which cells we can teleport, and then we'll run something on this maybe graph of size with only n vertices. Still, I'm not sure how to do it. Let's see questions for now. Tourist already got AC. Well, he's better than me, and also I think he didn't have to explain everything, all of his thoughts. It's for sure. It's slowing me down a little bit. For example, in the previous problem B, I think I would be able to solve it, to come up with a solution in like a minute and implement in, I don't know, 10 minutes. Of course there could be bugs, but explanation takes a lot of time. So let's say that tourist with explanation would finish this problem in maybe 5 more minutes. Okay, not now. And okay. Okay, I think I have some good idea. If we know that in this one pattern we can teleport between some empty cells, for example this set of cells, because they are somehow connected through the middle, then what I want to say is, if we are in one of those cells and we can get to one of those cells in some different pattern, yeah, so this pattern also occurs like in every occurrence, in every copy. So if we start, I don't know, if we start here, it means we can reach any of these cells. And what I think is that if we can, from this occurrence of, from this connected component, this is what it is, we can reach any place in this connected component in other copy of the grid, that I'm saying the answer will be yes. because it also means, of course, it doesn't have to be a grid that is copied just to the right. I'm saying that this could be any other occurrence, and if we can get from here to here, for example, it means, since this is connected component, also we can say that it means, I don't know, from some element, let's say this one, we can get to this one. And since everything is copied many times, it means we can also get here. And so on. So if from some cell in one occurrence you can get to the same cell in some other occurrence of the grid, the answer is yes. Moreover, I claim that otherwise the answer is no, because if we can go infinitely far away, then we must visit some cell twice. I mean, at some moment we will be at some cell. I'm saying at some moment in the future there must be a repeated cell. Otherwise, we could make only n² steps, because every cell we would visit only once. So if the walk is infinite, then there must be same cell visited twice, maybe in different occurrences of the grid. So, for example, maybe this cell will be visited and this cell will be visited. Then I claim if I can go from here to here, I can also go from here to somewhere around here, and so on, infinitely far away. So I think that now we have this, after some pre-processing we understand the frame, and now we want to connect adjacent frames to merge some connected components and do something with that. I'm not yet sure how to do it, but I think it will give us a correct solution. Just check if the starting cell can be revisited on another grid. Yes, just the question is how to do it. Because I guess it would work to copy our grid like 1,000,000 times, like 1000 by 1000, but we don't have enough time because the grid is itself n² with n like 1000. So for some other component, let's say that there is some next component, so it's also here, then of course it's easy to see what are edges between different components, but the fact that we can go between these two cells doesn't mean that from this connected component we can get to this connected component. So I'm thinking about using some find and union, some merging, some connecting of connected components, where I would say now that these two together create one connected component. But of course, maybe, okay, maybe I have an idea. Maybe we can do things brutally, so just find, so we have this starting, connected component, and we also know that we can go here, so let's just mark also these cells as cells we can get to. And from them we also can get to some other cells, and let's mark all of those cells as visited. And it can be, like, of course, we can get infinitely many cells, but we can stop when we reach n square cells. Yeah, because if we reach more than n square cells, then for sure some cell is repeated. So the thing with moving like this means the answer is yes. And otherwise the time complexity is up to n squared. So actually we don't need to consider this frame thing. We don't need any preprocessing. We don't need to understand what are connected components. We just run DFS and we try to get new cells that we can reach to. Do you have questions about the solution, or can I go to implementation? And by the way, I enjoy this problem a lot. Hello Rishabh, good to see you again. So we're solving right now a problem, infinite maze. I must sign in. Okay, nice hacks not to show you my email. Okay, I showed my email. No, it doesn't matter. And now I think I can write. Yeah. This is a problem we're currently solving. So I thought I am a genius because I understood that since all my monitor is recording, I can move a window down. So I also didn't see what I was typing, but I thought that then I'm not showing you my email ID, and I didn't realize that in the next page it will show something like hi email ID. Okay, no moniker. Hello Errichto, thank you for making this live stream. You're welcome, and welcome back. I think I also saw you in one of the previous streams. Rishabh missed my last stream. Okay, you can watch the video. And let's move to the implementation. What should be quite easy, I think. So this is... what problem this is? Let's call it maze. Nice CPP. Well, the issue I have is that I only have one big monitor, and to see if everything works correctly, what I do is I have a laptop here, so I indeed see the stream, and I can see on some different monitor if chat is moving, if something new happens. But what I can do is move some window outside what you see and do something there. I must fix it one day, maybe by, I don't know, for a moment turning something off in OBS or just buying a monitor. Okay, so let's read the input. There is some, so let's copy the two magical lines that make scene fast. Read dimensions of grid. Read the grid itself. And there are a few ways to implement that. One I can think of is to create a set of pairs, and then also a queue so I would implement it as a vector. This is something that I still have to consider, and to set I insert all the visited cells, and when this size of this is bigger than h times w, I stop, because I know the answer is yes. Well, yeah, if it exceeds that. But it gives me extra locking complexity. I don't want that. So instead, let me here create an array visited. Of course, here those values could be outside 0 to w-1 and 0 h-1, because it could be in some repeated pattern. And here I'm limited only to 0 up to something. But it should be okay. And now, okay, so just a queue. Okay, and also let's say I want to know for a value of row call, so row call between 0 and h-1, w-1, I want to know what exactly cell, which exactly cell is visited. For example, if grid is 3 times 3, and we are talking about a cell 0, 1, then if I visit a cell, let's say 6, 1, then I will mark here, in visited, I will mark 0, 1 as visited. Let me write a full word. And in where of 0, 1, I would put this pair to know, like, among copies of this cell, which one is really visited. And then, if new copy is visited, then I mark something as done. Then I print yes. Okay. Let's find the starting cell. And now visited of this cell is true. Where of row call is just this pair. And to queue we append, and place back is better in C++. So here we append a pair. And now we iterate over elements in queue. Let's say row is this value, call is this value, and we want to iterate over 4 directions. And let me just hard code those directions. Now I iterate over one of 4 directions. And what now? Let's also, as a to-do, because I'm not sure right now, I will see, r row call in intervals 0h1, 0 w-1. I'm not sure. We'll during implementation think about that. The real question is why max over max? Because max has some different meaning. Max is maximum of 2 numbers. This is how it's used. Actually, I'm cheating you a little bit. I don't like using caps lock or shift. So actually, I use something like this in actual competition. When you go through my submissions in Codeforces, you will see max written like this. This isn't a good convention because it's better to name constants as big values, but then I couldn't use max. So I use max because I use something like this, in fact. I'm just, for the sake of stream and implementing things nicely, using uppercase. Can you explain a little bit how those lines make input fast? I don't use scene every day, so I'm not sure. I think this one turns off the synchronization between scanf and scene, and cout and print. So without this line, you can write cout 5 print 6, and 5 will be before 6. But making this synchronization is time consuming for program, because I don't know, maybe after every printing it has to flash. I'm not sure. So with that you say don't flash, I will only use couts. And I don't really know what scene type is. Maybe it's something similar. IOStream has to synchronize with scanf print on each input. Yeah, and I think this is about the first line, and I'm not sure about the second one. I think you can't use both once you write that line. Yeah, you can, but the synchronization is off, so they can like interchange. Something can be printed in wrong order. What does the array where contain? Okay, so let's move to our drawing. So, for example, this cell, this one, has coordinates 0, 1. So this cell has coordinates 0, 1. But if we start somewhere, we go along the grid, and we, let's say, enter this cell. This cell has coordinates, what? Sorry, it was not 0, 1, it was 1, 0. This cell has coordinates, what? 7? No, 1, 6, I think. So then we would write in code where of 0, 1, sorry, 1, 0 is per 1, 6. So it denotes which cell is really visited. And why we need that? Well, we will find out in a moment. Scene time means that the program will not flash output buffer before asking for input. If you are not writing interactive program there, then this can be used. Okay, thank you, Bluefog, for a lot for information. So this makes flashing even like less frequent. If you just print a lot of stuff, you will never flash in between, unless you want to read something. Okay. So here, if not visited of something like this, like here R2 and C2 can be huge numbers, maybe exceeding 1000. So we can't use it without modulo. Here we kind of check if this cell like moved to the first grid, if it was visited. So if any copy of this cell was visited. If not, we mark it as visited, where we save as R2C2. And to Q we append R2C2. Okay, so these numbers can be huge, we say. So can be not from 0 h-1. Okay, otherwise, now is where an array where will be used. If where of, so it's already visited, and if this very same cell was visited, but otherwise we print yes. Because it means we got a new occurrence, a new copy of this cell. And if everything is finished, we print no. And let's see samples. Okay, now it's a good time to talk about important flags that I recommend you using. Sometimes you get undefined behavior or just seg fault without any extra information. Here you can see that my program told me that I got out of bounds, I accessed an index -1 in some array. What is awesome to see. So I recommend using some flags. I'm here pasting my flags with sanitizers. And I also have a button to compile without sanitizers and instead with optimization O2. And actually, if I right now compile with this other button with optimization, here I just get segmentation fault. So this is what you normally would get. And but a button for slow compilation will give me something like this. And we can do even more thanks to flag -g, because we can run GDB. And okay, I expected, sorry, it isn't important now. I wanted to say that it will tell us a line where a mistake happens, but forget about it because it's already here. 43. So here we have out of boundaries, and if you understand modulo, you will understand easily that it's because negative value modulo something isn't computed correctly. So actually, let's create my modulo function. Result is a modulo b, but if result is smaller than 0, then result does equal b. So this is something that computes a modulo b, but moves it to positive values always, not negative. And everywhere here we need f of this. I think R2 can be -1. Yeah, but with this after modulo we want it to be between 0 and h -1. So I just have to change it in all the places. I think I did. I overwrote my input file. Yes for first input. Yes for second input. That's bad. So why did we get yes for the second input? Well, we print yes at this moment, so let's print some debug. So let's print R2, C2, and also this pair that says what is a cell already visited. And let's see what happens here. So my program thinks that it can visit 1, 4 and 1, 0, what is stupid because it's a cell in the wall with wall. And then once we print this, it's very easy to note what is wrong. I leave it to you. So this is something easy that we just don't check. So maybe one of you sees it right now. And this should be very easy to fix. Just we have to add like one line. It seems like using an ordered set with some custom hash function would be fast too. How do you know to do this more complicated thing instead? Well, an ordered set has some overhead. It's a bit slower, like it has constant time, but it's a bit slower because of its implementation, some buckets, some even constant number of collisions, and also sometimes it's possible to be hacked. There was recently a post about it. By Neil. Let me check. So this is an important lecture. So this guy explained a few things about random functions, about hashes, and I recommend reading a few of his blogs. I recommend reading a few of his blogs because you will learn new stuff. And an ordered set wouldn't be much easier, I think, here. So this is the answering it. Reshap, not visited. I don't think it's an issue. So I will tell you what is wrong. Where I think it's very easy to see if you take a look at this output, because my program said that it got to this cell that contains a wall. So apparently I don't check if something is a wall, and indeed it's true, I don't do it. So here, if grid of this cell is a wall, continue. And now it's okay, at least on samples. And we here print something extra, but it's done with CRR, so it's okay. Let's submit. Okay, I must log in. Yeah, I think it's invisible. And okay. Submit. So let's see if it works. And also I must say that I enjoy a problem like this a lot, because a solution turns out to be very easy. And of course, maybe not of course, but I think a solution with set or an ordered set would be simpler. So you can here start with just set and this queue, or even I think it would be better to just, because this is BFS style. So I think I can even quickly implement the alternative solution. So it would be just I wanted to do something that will be for sure fast, but alternative solution would be create a set or an ordered set for visited, create a DFS. Okay, I still need this function. Create DFS. Insert to set. Iterate over directions. If set already contains this pair continue. If grid of this cell contains a wall, continue, and otherwise DFS of R2C2 if S size is smaller, greater than the product return. I need dimensions globally. And now if S size is greater than the size of the grid, print yes, otherwise print no. It compiles. And we got two yeses, what is not okay. It seems that Codeforces queue is stuck, so in the meantime let me try to debug my solution. Firefox prompt to save it, and you could see the password length. Just hide the scene in OBS when you want to hide it. Yeah, I'm not very familiar with OBS, so I wanted to do a quicker hack, but you submitted wrong code, I think. Yeah, that might be correct. So I submitted BCPP. Nice. And let's figure out why it doesn't work. Nice too. Well, I can print visited cells. And they don't seem to repeat. So maybe. What cells do I print? 1, 2, 0, 2, minus 1, 2. I shouldn't be able to get to this cell, so something is wrong. Minus 1, 2 shouldn't be accessible. This looks okay. Row H, call W. Okay, R2C2. And now this is something that would be printed a lot, so I prefer to remove it because it would affect the running time. Maybe it would still be okay. But yeah, we get now much simpler solution with DFS, but it will be slower. I can here use unordered set and add some hash function. I think it will still pass right now with set. And the queue is stuck, so we will not see. Yeah, thank you, Alexei. You're right that it should be R2. There's an icon button, and you can click it to toggle visibility. Okay, let me. But I see a lot of things, but I guess that video capture device. Nope, screen capture. Okay. So this is quite easy. I will use it in the future. And thank you for help. Thanks to Hochol for this problem. Yeah, I thank you a lot for this suggestion. So, Alexei, was it you who suggested the problem? Because I enjoyed it a lot. This is, I think, a very nice problem. Let me see who was an author. I submitted a set and ordered set solution a few minutes ago, and they both get 10 minutes exceeded, but maybe yours will be faster. We'll see. Some very small improvement will be to here, instead of count, to use if f, let's try to insert second element of this function. Insert says if we inserted, if we indeed inserted. So let's first do this, and then we run DFS recursively, and here we don't have to. So now I removed count. I think it should work. Yeah. So this will be like 2 times fewer operations on set, what might be important. You can also bind that to some key. The issue with that is that so with a second stream I would see OBS on my side immediately, so I would know if I indeed pressed a key. I don't trust my keyboard and myself to be sure that I pressed a key, and it was once, not twice. Some like typos happen and I can hit a wrong key, and I see no way for me without a second monitor to see automatically, like without opening OBS again, if I press the button. Okay, so let's submit again a new faster version, and I hope that at least one of my 3 submissions will pass. So of course first one will not pass because it's a wrong code. Okay, we can, I guess, move to the next problem. It doesn't make sense to just stare at these submissions and wait. And yeah, the issue with second string is that my desk is quite small, so I can't get a big second screen. So now we will move to, since we had, I think, at least 3 proposals previously, and I would like to, okay, so maybe a new voting. So one will be C from yesterday cases, 3 will be binary sequences, the previous one, and let's say that vote 5 means something else, so likely a problem from maybe a contest 2 contests ago. So yeah, I'm not putting it as 1, 2, 3 because we already used 2. So choose whether we do 1, 3 or 5. Three, 5, 5, 5, hooray, a tie. Let me see in the meantime what problems there are in some recent contests that we can solve. Like, I prefer short problems maybe, like short in statement, because then it's easier for audience to understand the problem. Also, I want to see who is an author of this problem. Okay, so somebody said Hochol, so kudos to Nikita Glashenko. It was a very, very cool problem, because it was something that looked complicated but and was quite easy to understand, the statement, and the solution was short, and it was about coming up with a solution. So kudos to Nikita. Okay. So half the people prefers 3, and people that want 5 also will be divided among like different problems, so I think 3 is a better option. So binary sequences. Let me find that again. Maybe I have it open in Chrome here. Yeah, okay. A link for you. And also what this is. Technocope. Maybe I should put a link instead of a number because this will be easier. I'm not sure. Oh, okay, so it's Technocup round 1. I'm not sure about a good convention. So okay. And let me read the problem. Vasya has a sequence of numbers. He can take a number and swap some to bits in its binary representation. So first observation, the number of bits will be constant, like will be fixed for every number. Vasya names a sequence as good one. If using operation mentioned above, he can obtain the sequence with bitwise exclusive OR of all elements equal to 0. For the given sequence, Vasya would like to calculate number of intervals there, such that this sequence is good. So can be turned into something with XOR being 0. So XOR being 0 means that at every position the number of ones is even, because then they will XOR to 0. So I would say the question is, what is the number of... and I said we can swap bits, so the number of bits in the number is fixed, but we can in any way rearrange it. So for sure the total number of bits in an interval must be even, otherwise XOR can't be 0. Other than that, I have some idea. Sorry. So this will be binary. What is here? Doesn't matter. Binary. So basically, every number is described only by its number of bits, like the number of ones it's in representation. So we actually can say that the input is the sequence of numbers, where every number is the number of bits in that thing in the input. So for example, here, well, I'm not going to convert that, but maybe I can. 6 has 2 bits, 7 has 3 ones, and 14 has the same as 7, right? So it's 3. So this input actually can be treated as 2, 3, 3. And now we imagine this as 2 elements, this as 3 elements, this as 3 elements, and we want to pair them up. We want to, like, for every bit here, for every element here among of 2, we want to say at what position it should be, and it must be paired up with something among different numbers. So this is a complete like rephrasing of a problem, that we are given a sequence of numbers, each representing the number of elements in some, I don't know, set back. And we want to create pairs, like disjoint pairs, such that every pair contains elements from different backs here. So for example, one from this place, one from this place. And one obvious observation is that the sum must be even. And the next one is that if one number is big, then it's impossible to, the answer will be no. Because we can't pair up all of this number of all of elements from here with other numbers. In other words, because this in the original problem represented some number with 9 ones. We can't, no matter what we'll do here, we can turn off only 5 of those ones. So I think that the two conditions are sum is even, and second, max is not greater than rest. So in other words, max and of course rest is equal to sum minus max. So something like this must be true. 2 times max can't be exceed sum. Maybe it will be easier to write it this way, but not to care about rounding. Let's leave it like this. And we know that these conditions must be true, and we didn't prove that they are enough. I think they are, and I'm saying that because I saw similar process, I saw similar like problem, lemma, and a formal proof would look like this. If this condition isn't true, then let's say it's obvious. We can't create pairs where every number is in exactly one pair. If this isn't true, then this maximum is greater than the sum of the rest, so it can't be pair up. And the hardest part is to prove if both of these are correct, then we can. Well, the proof goes like, I think, every time greedily you pair up elements from 2 biggest numbers. So in this case, that of course here the answer is no, because the maximum is too big, but let's say we have something like this. So I'm claiming that we greedily should every time choose 2 biggest numbers. So first we would get from 6, 9 to 5, 8, then 5, 8, 4, 7, 3, 6, now 5, 2, it doesn't matter which 3 we choose, now 4, 2, now 3, 1, and so on. And in this greedy solution, what I claim is that the sum will remain even, and this will remain true all the time. So this is like, you must prove it with some formulas, simple formulas. Maybe to prove this you must use the first fact, because for a sequence 1, 1, 1 it isn't true. So maybe we must use the fact that sum is even. Because here if we change these 2 to zeros, we don't satisfy this inequality anymore. But generally, when we have something, if after the change maximum will remain, the same number will remain the maximum. So here we had maximum here, and after a change it will be still maximum. Then this will hold, because in other words, well, it's easier to prove, so it's something like this. Because after changing, by pairing this with something from the rest, we decrease both these numbers by 1. Okay, so it's easy. And if there were if there were more than one maximum, Okay, if there were exactly 2 maximas, then again we will decrease both max and rest by 1, so this will still hold. And if there are more than 3, then what happens? Max will remain the same, and rest will decrease by 2, but we know something more if there are at least 3 maximus. We know that right now, I think even 2 times max is doesn't exceed rest. If there are 3 maximas, then maximum is smaller or equal than the rest, and we can even say that 2 times that is smaller or equal than the rest. And from this you will get this condition. Except for, I think, the case where we have 3 ones. So then we will have an issue by 1, but for even sum it's true. Okay. The queue is working again. You have AC, let left for previous problem. Okay, thank you for noticing me. Status. So surprisingly, it was a good idea to write it this way. I didn't know that set will be so slow. We can try to squeeze it a little bit more. Maybe I will try it in a moment after this problem. Okay, so this was about the proof. Of course, I didn't prove it formally in 100% because I'm not going to go through these formulas and cases. Like, it will take a few minutes. I just remember that something like this is true, that you should pair up always two biggest numbers. Okay, so now we have the problem becomes something completely else because we want to find the number of intervals where this is true. Or equivalently, 2 times max doesn't exceed sum. And now what we can do easily is to write some brute force. That's something. Previously, like without these observations, I think it was impossible to write a polynomial time solution. Magical lines to make scenes faster. Scene n. And read the sequence. And we can, well, change each element to the number of bits that are set to 1. Actually, those numbers can be long-longs, so I must create a long-long here, read it, and here use build pub count ll, I think, or maybe 1l, and for x. So it's built in. Sorry for messing it up. Yeah, so this works for long-longs. And now this sequence isn't the one from the input, it's instead the numbers of ones, something that we want to work with. Let's see if it works for the first sample. Two, 3, 3. So as we expected. Okay. We can write a brute force because it's quite easy, to make sure that our conditions are okay and they work for samples. So I iterate over the left side of interval, right side. I want to gather values. in this interval. Sort them, find sum, and now if sum modulo 2 is 0 and maximum is the last element after sorting, so if 2 times last element is what? Not greater than sum, then plus plus answer, and print answer. Two for the first sample, it's correct, and for the second one, it's also correct. So it took me just, I don't know, up to 2 minutes to implement. I see a lot of you giving me advice. Yeah, thank you, Bluefog, for using long. Yeah, but built-in pub count wouldn't work. You must add LL because otherwise it will compile but work incorrectly, what sucks. Could the next problem be contest? We'll check out later. I will check it out later and we'll think about it. Okay, one thing. So it doesn't give us a good enough solution, but here, to just improve a little bit complexity, we could, instead of sorting values, we could just find maximum. So let big denote maximum, and here we will do our maxi function. Just big is max of big and x. So this should be, we have n square intervals, and here we have O of n, so the total complexity is n cubic right now. Let me create a very simple generator for that. So of course, I repeat, this isn't something that is needed to solve a problem. I'm just showing you different possible things. When you create a generator, it's good to give n as the first value. Well, if you want to make it random, so to every time it would print something random, something else, then you would have to pass also seed, but here I don't need it, and just n times I will give it like what, round modulo 10, so a random number up to 9. And here let's put an empty line. And notice that I don't hard code here n. It's stupid. It's better to check here if it works as I expect. And now I can measure the time with time function. And for that I always compile without debugs, instead with optimization O2. Now it's like 10 milliseconds. For n1000 it's 300 milliseconds, and for 5000 it's very slow. So it makes sense that it's n cubic, and let's improve that easily. Instead of for one fixed L, instead of iterating over R, so the end of interval, and then seeing if something is true but in linear manner, let's here create sum and maximum. And here we just, when we extend interval by 1, we just to sum add this new interval. We also consider it to be the biggest value. And that's it. So this is big. And with O2, it's now 40 milliseconds. We can also see if For 1000 the answer is the same. Well, here for 5000 the answer isn't the same. Okay, that's suspicious. So previously it was slightly different. Sum doesn't overflow. Okay, it's worth investigating. So let me copy that to like what, bin2. And well, let's see if our new program solves inputs correctly. Yes, it does. Okay, did I make a mistake? Sum plus equal, big, maximize. Here I changed values back to big. Okay, I think that this was wrong. So the previous version was wrong because I removed sorting values, and here still it was values back. Okay, makes sense. So now it should be okay. Again, check for samples, it's okay, and it works fast. But for like what, 40,000, then it needs seconds already, like 2.5. And for what is the, here we have 300,000, what is much, by far too much. And now we must do something smarter. So a very important thing to notice when we moved from these numbers to our new numbers is that our new numbers have values up to 60. So at this moment we make AI to be up to 60, what is quite small. And from this I see that for one fixed L, for some time, like for some R, there will be some maximum, then maybe there will be a bigger value, so bigger maximum for some time, but those changes will happen only at most 60 times. So O of logarithm of the number here. So what I want to do, more or less, is to, for every L, to quickly go to the next place where a new bigger value appears. So let's say that the function is 2, 3, 1, 1, 2, 4, 2, 5, 6, 3, 6. So, okay, let's say that I consider L at this place. So first, all intervals ending somewhere here have maximum 3. So, just for your notice, I'm just focusing on this part because this is harder part. The sum is even thing is quite easy to like to deal with some prefix sums, because sum is even means the difference of two prefix sums must be even. So just prefix sums must have the same parity. We'll go back to that, but we focus on harder part. So if L is here, for some time we have maximum being 3, and then we have a new maximum 4 for some time, then we jump to 6, and everywhere here we have, ending here, we have maximum 6, and so on. So if I start something, I think I should be able to quickly go to the next place where something bigger is, so up to this place. Then I know that from this place this number is the next bigger one, and so on. And while I'm with some intervals, for example, I know that L starts here and I want R to be somewhere here. I know maximum, so this condition becomes sum must be greater than or equal to this. And it's possible to do with some binary searches, prefix sums, and so on. And you can go now to implementation, and you will I think it's hard to avoid n times log square. Maybe this is some issue, but it's possible to be dealt with by doing some preprocessing. So if you create an array of this size, I think it fits in memory. Yeah, it should. From every place, for every number, you know where is the next number, the closest one, or maybe for every place to know where is the next bigger number. Actually, it can be done in by linear preprocessing. When we go from right, we maintain some stack, and then for every new value we will know in this stack where the next bigger value is. But this isn't important here. What is important is that we can do something smarter. So you should think a lot before implementation if you want your implementation to be easy. And here, actually, when I scrolled up to this condition and it was expressed in this way, I noticed that we know that maximum is up to 60. So this is up to 100 plus 20. So for all big intervals, this sum will be greater than that. So numbers equal to 0 are like impossible here. What is an important thing? So every number has created right now after build pop count. Every number AI is at least 1. So every interval of size at least 120 will have this condition satisfied. And actually, I think even by looking at this condition, we even can say that every interval of size 61 will also have this condition satisfied. So the easier approach will be iterate over small intervals brutally, naively. So I guess with this function, just r stops, maybe it will be min n and l plus, I don't know, 670 to be sure, just some magic. And for long intervals, we only care about this thing, because this condition will be satisfied for sure. AI up to 10 power 18 is the tricky point of this problem, but remember that what we notice is that only the number of ones matters. So now, after this thing, our AI with what we work with is up to 60. So the tricky thing to notice is that this condition, that it's at least 1, because this allows us like easier implementation. Okay, so I want to count long intervals that satisfy this condition. And let me just first count all intervals that satisfy this condition. And for that, let me create prefix sums. Is what AI. If it's not the first element, add the previous prefix sum. Okay, and now what matters is the number of even and the number of long intervals. The number of even and odd intervals, and we only want to count long intervals. So one approach is to maybe, I don't know, move with 2 pointers, and for everything to only count previous prefixes that are further away than 70. And the next possibility, I think easier, is to here count all intervals, including short ones, and here, when we iterate over all small intervals, we know which intervals we double counted, which intervals we counted unnecessarily. So actually, I think here we will do something like this. Here, count all intervals satisfying this condition, where sum is even. And here, so we can do it in maybe this order will be better. So here we subtract those where sum is even, but 2 times max isn't smaller or equal than sum, because those were counted unnecessarily. And then we don't have to do some complicated 2 pointers here. The solution will be easier. So here, subtract those where sum is even, and this condition isn't true. So the opposite is true. And then subtract 1. How to train to IOI? I can answer after solving this problem. Let's try to keep questions like this, general questions, between problems, and while solving a problem, let's focus on the problem. Okay. So count intervals where sum is even. It's those pairs where the parity is same. So let's count prefixes with odd and even parity. Also, it's something that you should just spend a few seconds each time thinking whether you're interested also in prefix of size 0. Here you should, because when you consider, for example, this interval of values, it's equal to saying that it's the prefix up to this point minus empty prefix. So actually I will increase even by 1. It's for empty prefix. So we should consider n plus 1 prefix sums. Okay, and now what is answer? Well, we must pair even with even or odd with odd. So let f be a function that, given the number of prefixes of some type, returns the number of pairs among those. And I think it's something like this. For example, for x equal to 2, we would get 2 times 1 divided by 2, so 1 pair. I think it's okay. It's better to create this as a function. Of course, it also can be done here. I just didn't want to scroll because I knew that I only want to use it here. This way is better rather than writing something here, and making mistake easier to do. Also, without a function, we could do for a in maybe for x in even odd, answer plus equal f long x times this divided by 2. So this is equivalent. Let's see on samples. It works. Let's see on this big test. It works. And we can, since we already have generator, we can see that it's quite fast for the maximum possible n. Let me submit. It's binary. And now it's a time to answer a question: how to train to IOI? So generally, if you ask how to practice, how to get high rating, how to train, the answer is practice. So solve problems. If you want to train for, insert some name of competition, you should focus on problems from this competition and to those areas. So for IOI, the most valuable thing is solving problems from old IOIs, because they are closest in terms of style. If you want to practice for ACM ICPC, the best possible training, even if it doesn't have the best quality problems, but it is high quality, is to solve previous finals. So for example, when I trained for ACM ICPC, I tried to never see any problems from old finals, even when some other team from my university came for finals, went to finals, and we wanted to cheer up for them and we wanted stream from the contest. We tried to cover stream and turn the sound off when organizers talked about some problem from the contest, because once we were close to our own finals, we wanted to ourselves write virtual participation of that, because it's very valuable. Maybe not necessarily one day before the finals, but when you already have your team reference document with codes and so on. And for IOI again, it's old problems from finals are very important. So you should solve some of them, and maybe problems from 2 last years that are very important, you should stay for quite late, maybe 1 month before you will compete. If you want to pass your national stage, then focus on problems from previous years of your national stage. And well, you can read IOI syllabus to see what topics there are that you don't know. And there will be some hard topics. For example, I would say that BST or two-dimensional trees are quite hard. So if you still don't know, if you still don't know segment trees where you want to do something for interval and ask about something for interval, maybe it's more basic. Well, if you don't know Dijkstra, then first you should learn Dijkstra. I think Errichto's problem sets are nice. You can try to practice his contest on CF. Yeah, I recommend my problems. So you can go to my profile on Codeforces and go to problem setting. So problems that you only see me as a problem setter, there all problems are mine. And maybe more problems you can find here, Topcoder problem archive. But I'm not saying that my problems are best to practice for IOI. I think my problems for Codeforces are good to practice for Codeforces. And I think they are nice, so I recommend them to others, but I'm not saying that they are best to practice for IOI. So also you can go to Google Topcoder problem archive and then insert my name, and also you'll see a bunch of my problems. Okay. So this is accepted, hooray, and we can move on. Can you explain problem settings? I can and I will, but on a different stream. I think that while right now I teach you something and it's valuable, it's cool for you, I think it has quite small impact. Some small part of the community will see it. I don't know, there are, 30,000 people that compete in Codeforces quite regularly, and maybe in total 500 of them will see my videos, so it's a very small part. While I think how I can have impact on quality of contests and the whole community is to teach a bit about inventing problems and about creating them, preparing tests in Polygon. So for sure I'm going to do some videos about it. It's harder because I can't do stream where I invent problems that I want to use in a real contest, because I spoil problems. The nature of that is kind of bad. Also, I would prefer not to stream the whole process where I also discuss things with others. So it's a private conversation, for example, with contest coordinator or a tester or Mike, and I don't want to like show people my private conversations, right? So it's harder to do. Also, some other thing is that when in Polygon, if I right now log in here, then you would see a big list of my problems, and in that list also there are problems that I haven't yet used, that are, for example, for future Codeforces rounds. And I can't show you names, for example, because you also will see what is the difficulty of each problem. Like, for example, it's something is marked as div1b, maybe there are tags, maybe there is like a number of solutions or tests. There are a lot of things that I will have to care about when doing something like this. Also, I reuse a lot of generators. For example, when I generate trees, I have some generators for that, and I can take it from an old problem, but at that time I don't want to show you that problem if it hasn't been used already. So there are a lot of issues with that possible. I think all of it is possible to overcome. It just requires some preparation, and also I'm quite busy with like local Polish contest right now. So I prefer not to prefer not to spend time preparing other contests. This is why right now I'm not preparing any other contest, for example, for Codeforces. Tips for ICPC. I think I've just talked about ICPC a little bit. So tips for ICPC: practice contests for ICPC. Where do you work? Mainly it's remote work. So organizing contests is my, let's say, main job. Okay. Also, I work a little bit for Imtech, that is a Russian company located in Moscow, so also remote. It's a high-frequency trading company. Okay, we got accepted here, and I said that we can try to improve this solution a little bit. I'm not saying I will be able to improve that enough, but I can show you what I would do if I get time limit exceeded like this. So let's call it slow. Let's, in our generator, what we get? We get H and W. I think they don't have to be different, so let's say that I just get n from the arguments. Then I print it 2 times. And let's say that every cell is empty except for one. So if I is row and j is column, then print start as something. And I recommend always, when you write a generator, to run it first on something small to see if it makes sense. For 0, no? If it does something like you would expect it to do on small values. Okay, so we can create something bigger. $1,000. Okay, I got some implementation fault and I think I know why. Because my stack is limited. Yeah, it's 8 kilobytes, I think. How to do it? Minus s, something like this. So this would be, is it in kilobytes or not? Yeah, it's in kilobytes, so that should be 256 megabytes. Okay, let me run it again. 1 second for 1000 times 1000, and here it can be 1500, and apparently it's slightly too slow. I think my computer is slightly faster than Codeforces maybe, so I think I just have to optimize it a little bit. What to do? Okay, maybe modulo takes a lot of time. I'm not sure about it. I wonder whether the big running time is because of a set or because of modulo. It's quite hard to measure here. One very simple hack to limit the number of, remove one of 4 direction is to here pass the previous cell. Let's say that R0, C0 is previous cell. So here it will be -2, so something like this is fake value. And if I here pass the previous value, the cell from which I got there, then here, if from a new cell I try to go to R2, C2, and it's the same cell, then continue. And I don't have to check anything more here. So just from a new cell I will only check 3 directions now. Let's see. It's slightly faster, as I would expect. It was 2.2, now 1.78. We can submit that. But it's better to optimize it even more. But if it's already fast enough, I don't want to spend more time on that. One moment. Czy coś ważnego? Cześć. Za pół godziny. Okay, dobra, na razie. Sorry, I found. How to solve Codeforces div2 CND? What is the basic requirement for this? There is no magic about it, and it isn't different in concept from other contests or problems difficulties. It just some problems are harder than others. The more problems you solve, the better you will be. The more algorithms you know, as long as you know them well, the better you will be. Still time limit exceeded. Okay. What else we can do? So here, if size is already big, instead of just returning, because there is maybe a big tail of recurrence, maybe multiple DFS functions, like instances of this file, are in stack. So instead of just returning from this function, a better thing would be also to here, if this is too big return, but in a moment we will do even something better. Right now we got 0.8, so 2 times faster, and I think it's already okay, like it would pass. But here let's already print yes, and let's exit 0, what breaks from the whole program. And now we have, well, it didn't do better than adding a return here, but what we improved is that if we have a big tail, and now we see that this is greater than the size of the grid, still, for all of these cells, we'll run through this loop to the end. So let's submit that, and now I think it will work. Oh, okay. So I thought that here I see result for the previous submission. Okay, so maybe the previous small hack was enough to get accepted, and now just running time of this should be much faster. So if there are a lot of tests, maybe even this will finish testing earlier than this one, I'm not sure. Given two ranges L and R were something, I have to count how many primes, numbers, binaries, palindrome between. How can I solve this? Time limit is 2 seconds. I can say a few words about it, but you have to say what is the source of the problem. I don't like just solving a problem that somebody tells me without source, because it can be from ongoing contest, from like your ongoing interview, if you have 1 day to implement something, I don't know, code long, something like that. I think you can't post a link here, as only I can, but you can say from which contest it is. Yeah, so our recent submit catches up, so maybe, just maybe, it will be first. Can you do a code chef problem? Well, there is no reason for me not to do a code chef problem, but right now, like, we have a stream that is called Codeforces stream, so I don't see why I would change from Codeforces to something else. Okay. Okay, I thought that you're giving me a link to this problem about primes. Memory limit exceeded. Interesting. So the solution without exit 0 gets memory limit exceeded on test infinity. Let's see if our new solution passes that. Yeah, it passes. I think it's better because this is just a small time improvement. Just let's go back to this version. So right now we have this code, and if we remove this, the memory used in stack will be decreased, because right now in every occurrence of DFS we have these values in stack, and so we don't pass this, we remove that. So now we again have slightly bigger running time. Oh, it's much faster. It's wrong. I messed something up. Hooray! Accept. What did I mess up? Oh, binary. What I want to do? Okay, this is some different input. So I overwrote my inputs, and now I run it at something completely nonsense. What function is it? Slow. Okay, it's fast enough. So this is my second last submit. So this one, sorry, let's refresh. So it's this submit, but we've removed again this R0 C0 that meant previous cell. This was something that could improve running time a little bit, but it created bigger memory complexity. So maybe this will pass. Running time will be slightly slower than here, but memory will be better. Well, we'll see in a few minutes. Okay, so Naif, if you wanted that problem sourced, please. So this is some proposition from many contests ago. Also, it's 20 past 3, and I will be finishing very soon. Like, I want my streams to be roughly 3 hours, I think. And we are right now 3:20 already. But I can go quickly through one more problem. And I still not sure how long I should talk about one problem, because if I see a solution immediately, I can talk for 1 minute and I can talk for half an hour. For example, here the first two problems we were solving took quite a long time, and I'm not sure if it was a good thing, but well, maybe because of that it's explained well. Trees one. Well, I'm repeating that this is Codeforces stream, so this stream I will not do a CodeChef problem. I can read this proposal by div1. Also, let's see status. Time limit exceeded on test cell. So what was important was to do exit 0 here to just finish. Another thing, if that wasn't enough, here we see that it's just barely in time, because 2 seconds is time limit. Also, I would do some hacky thing. I would create a bit set, something like that. I think this fits in memory easily. So this has 10 power 8 bits then. So yeah, I even can be something like this here. Yeah, so this is maybe this will be better. I'm not sure. And here, instead of checking something in set, I would say if R2 and C2 are in this interval, then instead of set, let's just check if not bit set of R2 C2, then bit set we set to true, and we run the ifs. So this was my next idea. that maybe also improves running time a little bit. It depends on test a lot. Also, if we go to negative coordinates, it will never be run, it will never be used. So maybe better it would be to do what? To do something like this, I think. So we want to shift coordinates a little bit. So instead of, right now this covers coordinates from 0 to hack -1, we want to get from minus hack divided by 2 to hack divided by 2. Like to get some area around the initial grid such that we would quickly access those values, whether a cell was visited or not. So this would be my one idea. And the other is that maybe modulo is slow. So maybe, sorry, I removed something important. Where is F? Here is F. Maybe modulo is slow. So then with row and call, I thought about also passing row modulets and call the same. We saw it not passing in memory, so maybe short is enough. So here we need int, but here I think we only need short because its value is up to 1500. So these are some ideas that I also have. So I'm just telling you that it's reasonable. Something like this is a reasonable trick. Minimum spanning tree for each edge. I don't like graph problems, so if something isn't easy, no. How to get to standings of this contest? Okay. If something isn't easy and it's about strings or graphs, I prefer not to solve it on stream because it can take me a lot of time. So here I see that best people solve it in like 15 minutes, so I'm afraid that I would spend too much time thinking about it. For each edge in the tree, find the minimum possible weight of the spanning tree that contains this edge. Okay, so given a graph for each edge, find the minimum possible weight of the spanning tree. So likely we should do something like, okay, well, I see a solution, I guess. We are given a graph, and there are some algorithms to compute the minimum spanning tree. So a tree with n-1 edges that has the minimum possible total value of edges. And now for each edge we want to consider forcing this edge, like it must be in a tree, and now what is the minimum possible minimum spanning tree including that edge. And if this edge is inside that what happened? I don't know. If this edge belongs to the tree, to the spanning tree, then the answer there is the same as for the whole graph, the minimum spanning tree. And otherwise, I think we have the following situation. So we have some tree, minimum spanning tree, and we also have some extra edges. And for every such extra edge, let's say for every such extra edge, we want to know what if we force this edge. So the solution is to understand how trees work. the solution is to consider this once computed spanning tree and to see if we force this edge, then we create a cycle here. So just one of the edges on cycle must be removed, one of these. So we must find out among these edges, those, except for the added one, that are in the cycle, we want to remove one. So we want to remove the one with the biggest cost, biggest value. So we have a query on some path, what is the biggest possible value of edge. And to do it, I recommend jump pointers. It's just some structure, some technique. Basically from every vertex and for every power of 2, we know for a path starting in this vertex and going up for this length, this power of 2, what is the maximum possible value, maximum value of edge. So this is called jump pointers or binary pointers, and I think it's a cool technique. I'm not sure if there's a very good tutorial for that. If not, I will consider creating a video about it, because I think it's nice, I understand it well, and this is the whole solution. Actually, my friend gave me this problem. It was his university programming contest problem. Well, as I said, I have some reason. I explained it why I prefer a problem with source. Without source, I'm not going to solve a problem. And I guess we will be finishing in a moment. Sorry to those who proposed something and I didn't go through that. Well, let me read this problem, and maybe it's easy. Something's wrong. If it's easy, I also can, without implementing, say something. If I see a solution immediately. But this will be the last problem, no? Definition of GCD, so greatest common divisor. By the way, if G in word greatest is called G, then shouldn't it be like GCD, like in GIF, not GIF, like, right? GIF, so GCD. Let S be a set of exactly 4 distinct integers greater than 0. If for all pairs of distinct elements in this set their GCD is K, then K is said to be rank of this set. Given K and N, Dreamon wants to make up N sets of rank K using integers 1 through M. No integer is used in 2 different sets. Some integers can be not used. Calculate the minimum M that makes it possible. Okay, so we are given N and K. We want to create N disjoint sets, each containing 4 numbers, such that in every set their rank should be K. So for sure all numbers must be divisible by K, right? So if GCD must be K, then all numbers must be divisible by K. So I think we can just solve a problem for K equal to 1, and then for bigger K, we just multiply those numbers that we print by K. If we know, for example, here we have a set with 4 numbers, such that every pair has GCD equal to 1, then to get the same for K equal to, I don't know, 5, we just multiply every element by 5. So it will be 5, 10, 15, 25. So this is how we got to K equal to 1. And now for K equal to 1. I think we will be limited by even numbers, because we can't put 2 even numbers in one set. So first set maybe something like this, for example. The second set, if it contains a 4, then it can't contain any other even number. So I think this will be the main limit. Maybe just we will want to choose the next even number and 3 consecutive odd numbers. Should that work? I can implement that, I'm not sure. So no, it will not work, just not without some extra fixes. So we are optimal right now in terms of, we minimize the biggest number we use. So m is like the biggest number we use. So we want to choose some small numbers. The issue here is that, so we want GCD of every pair to be 1. Here it isn't true. But for every pair of odd numbers, if we choose 3 consecutive odd numbers, their GCD will be 1 indeed. The GCD of 2 consecutive numbers must be 1, because for GCD of a plus 4 is equal to GCD of a and 4, right? So if, for example, if we want GCD of these 2 numbers, it's equal to GCD of just first number 13 and 4, and every odd number has GCD with 4 equal to 1, so it's okay. It's just about pairing this even number with those. So we just require that, so here taking 8 would be fine. Then we have, well, maybe let's write first those numbers. Like the intuition tells me that if this is an easy problem, then this must be a solution, because otherwise it would be very hard. It would be problems like this often are NP hard unless there is a simple kind of greedy solution. So we have triples like this, and for every of them we want to put some extra even number. For sure we can't do better, because we say that we can't use 2 even numbers in one set. So just a question, can we put some even numbers here? I would put 2 here, 4 here, 6, well, 8 can be here, 10 can be here, 12 not, 14. Okay, so one idea is to just maybe greedily choose as small even number as possible, but I think I see a better way to just always choose the number that should be here or here. So for example, for these 3 numbers, maybe okay, what about always putting a number here? So GCD of every 2 consecutive numbers is always 1, and GCD of this number with the last number can be only 3, but we have here jumps by 6. So this number will never be divisible by 3. I ignore the midterm test to watch your stream. I will answer that in a moment. So since it's easy, let me implement that. Actually, let's make it a little bit more interesting for the end. Let me just write it in submit, how is it called? Submit area. So we read n and k. So this is some fun exercise if you know your language well. You don't really have to compile if it's easy. What we need. So this number will always be what? n times 6 minus 1 n times 6 minus 1 times k. We multiply everything by k. And what we print? We print x plus 1, x plus 2, x plus 3, x plus 5, and we increase x by 6, and first x will be 0. So first line will be 1, 2, 3, 5, and so on. And we must multiply each thing by k. Okay, looks fine. Format of output is okay, I think. We print line after line. This formula seems okay. Okay, let's submit. Language is also okay. If you are crazy, you can also try to type the whole problem without looking at monitor. It's a bit harder because you can't make a single typo, but it's also possible for short implementations like this one. Maybe here it will be quite hard because I had to print a lot of things, but for example, I once tried, like during some camp in the evening, we were playing around and I tried implementing given a graph, so n and edges, find the number of connected components. So I managed to write something like this with somebody was looking at monitor and he told me at the end that I had one mistake, and I was managed to from memory find this line and correct the mistake. But it's of course impossible to do for long problems. I can try that one time during stream, but well, it's harder for me to prove that I'm not looking at stream. Maybe I will have to do something like this. But it doesn't give you anything, just a fun thing to do. Okay, we got here, where was it? Yeah, we got accepted. So as you can see, you don't really need IDE to code. You can just code in Notepad on this. You don't need to compile. But I recommend compiling during contests. I ignored the midterm test to watch your stream. Do you think GPA is important? I love competitive programming more than some boring stuff at school. So, competitive programming is cool, and it's just like with, I don't know, sports, being good in football or something. If you're extremely good, then maybe you should consider putting it above studying or something. But if you're not, then it's a bad idea. I think similarly, if it's stupid to, for example, just try to become a YouTuber and ignore everything else, because you will not necessarily succeed. Depending on your situation, your country, studies will give you some job. Competitive programming will not necessarily give you a job. On the other hand, learning algorithms helps in coding interviews, and for some people it might be the easiest way to get to big companies and to earn a lot of money. So it is important, but on the other hand, maybe if you don't care about your studies and your GPA, then you will not be accepted anyway. Unless you're like tourist of competitive programming, but like you can't assume that you will become extremely good into, I don't know, a few years. Like only 1 in thousands of people can be like in the very top, right? Thanks a lot for your valuable time. Yeah, thank you, Bluefog, also for Thank you for those explanations about synchronizations and syntax. Okay, so this is something that I usually don't do because, not that I despise YouTubers, but I don't feel well by saying like, subscribe and so on. But this does help a lot because this boosts my videos, my channel, and more people can see it. So please consider liking the video, subscribing. For some other videos also, if you have questions, suggestions, leave a comment under a video. Also it counts to the YouTube algorithm. Just don't spam. And in the description under the video you can see my Facebook page. I started it 3 days ago, and I'm going to post some contest news, my thoughts, single problems. Sometimes I'm able to just invent a very short, simple problem from nothing. For example, you can see there one hello world problem that just I thought it isn't a good problem for a contest. I'm not going to give it in contest, but it's a good to just give it as a simple exercise. So if you use Facebook, follow me on that page, and I will try to schedule the next stream within a day. I'm not sure when it will be. Likely on, I don't know, something between Wednesday and Friday this week. I'm also not sure about what it will be. One of my plans is to do lectures about some harder topics, for example jump pointers. So it's something that I would prefer to prepare some materials first. Also maybe sometimes harder stuff like FFT. But I think this kind of interactive lecture where you also are able to ask questions is valuable. And if I have time to prepare, I'm also able to show some complicated stuff that is that also red people can watch, or even very high-rated people. And one of other things that I will also for sure do in the close future is some more problems from Polish Olympiad, because they are quite hard and they don't have editorials in English. For example, so usually here you can go to tutorial and find the problem, Dreamon and sets here, and you will see a solution. Of course it's explained shorter, and it's just providing you a solution. What spoils things a little bit, it's better to give just a hint first, to see some thought process, not just to jump, okay, this is how we do it. So first, I guess you saw me not really implementing a solution first, but experimenting, seeing that something is with even numbers, then with 3 consecutive odd numbers something is true, and so on. But still, solving problems from Codeforces that have editorials is a bit worse than solving something from our National Olympiad. I do share among my friends. Thank you, Sazat, if you want to share with your friends, especially those interested in algorithms, programming, or maybe liking maths, then do share it. I would consider not using Facebook, because that currently does not seem like it is going to rise anymore. I think that Facebook is convenient because many people use it. So it's much better than me creating a new website, I don't know, a blog, some WordPress website, because then you have to redirect your people to that website. So I think it's much more convenient, and it will bring more people to use Facebook, and this way also maybe your friends will see some stuff, and also they will like it. Can you teach some algorithms, maybe prepare them first and then do a stream of that? Yeah, I said that. Facebook is easier to reach, I agree. And yeah, that's it. So thank you a lot for watching and for chatting with me here. It's much more pleasant than me just solving problems and I'm glad that you also suggest problems. And when I decide about the next stream, I guess so far I post every time on Codeforces, but the best way to see it is that I schedule the video. So when you see my YouTube channel, when the next stream is scheduled, you will see it now with some countdown and some exact date. So just check it out sometimes and you will see when exactly the next stream is. And also I'm going to create some shorter video. As I explained at some moment in the past, I think the biggest thing in YouTube and, well, in internet about algorithms is people learning for coding interviews. So I'm going to prepare some short videos with easier problems, because coding interviews are easier than Codeforces div1, but it should bring more people, and I hope it will also make some people participate in Codeforces problems and, well, join the competitive programming community. So thank you again, and see you next time. Bye bye.